Hi everybody, today I'm going to share with you this video in English. I usually share maths and physics videos in this channel in French, but a lot of my followers, English-speaking followers, asked me to share more and more videos in English because the automatic translator doesn't work perfectly on YouTube, and in order to help all of my followers, I decided to share some videos in English in this channel. I have already shared 2 videos, and today the integral that we are going to calculate is really interesting, so I decided to develop the correction in English. Of course, English is not my native language, so if there are some mistakes, if there are some suggestions or terms I don't use correctly, don't hesitate to correct me on the comments. If you want me to share more videos, if you have some suggestions, some exercises you want me to correct, don't hesitate to comment on this video. If you want to have private lessons with me, you can find my WhatsApp in the description of this video, and don't hesitate to subscribe to this channel. It's gonna help me to get more and more visibility on YouTube. And let's start correcting this really interesting integral. So guys, the integral that we're going to calculate today is the following. It's the integral from 0 to plus infinity of dt over the square root of t times 1 plus t to the 3rd power. And the technique we're going to use today is the technique of substitution. So let's consider the new variable u, such as u equals to 1 over t. U equals to 1 over t. It's a really interesting and effective technique, and this change of variable, this substitution here we have, is really classical one. So the first thing we're going to do is we're going to modify the borders of the integral. So when t equals to 0, so here it's a 0 plus because we are between 0 and plus infinity, so the variable t is positive. So when t equals to 0 plus, u equals to 1 over 0 plus, and 1 over 0 plus is plus infinity. When t equals to plus infinity, u equals to 1 over plus infinity, of course, so it's 0 plus. Okay? So the first thing we can do here is to modify, to change the borders of the integration. Then we have to differentiate t and differentiate u. U equals to 1 over t, so du equals to the d1 over t. So if we want to differentiate 1 over t, the derivative of 1 over t is minus 1 over t to the 2nd power squared, dt. So du equals to minus 1 over t squared dt. Okay? So if we want to calculate dt, it's minus t squared du, so t equals to 1 over u, so it's minus 1 over u squared du. We will replace the variable t now using this new variable u. And this is going to give us a new formula. So the initial formula of the integral is the integral from 0 to plus infinity of dt over square root of t times 1 plus t squared, no, just t here, to the third power. And when we change, so this border 0 is going to be plus infinity. When t equals to plus infinity, here we have 0. we can replace dt by using minus 1 over u squared du, and we are going to replace also t here. So t 1 over u, 1 plus 1 over u to the third power. So let's now try to simplify this expression. So you can notice that we have a minus 1 here, so this negative sign is going to change the borders we have here. So it's the integral from 0 to plus infinity of 1 over u squared du, and here we can simplify inside the square root. So 1 plus 1 over u, it's u plus 1 over u to the third power, of course, equals to integral from 0 to plus infinity of 1 over u squared du over, and here we can simplify, so it's u plus 1 to the third power over u to the third power, and u times u to the third power is u to the fourth power. So u to the fourth power here, and you know the root, the square root here is going to change the expression below. So here 1 over u squared, because the root square of u to the fourth power is u squared, and here we have the square root of u plus 1 to the third square, to the third power. 1 over u squared du, so we notice that we have 1 over u squared in both below and above, so we can simplify, and the integral we have is the following. The integral from 0 to plus infinity of du over u plus 1 to the third power, and the square root is equivalent to having 1 over 2 in the power here. So u plus 1 to the third power, and all the thing to the power 1 above 2. So perfect. So here it's really interesting expression, because here we can notice that the expression is the derivative of u plus 1 over u plus 1 to the power 3 above 2, okay? We have a very interesting property. The property is the following: when you have the derivative of u above u over u to the n power here, this is derivative of u minus n. It's equivalent to 1 over minus n plus 1 u minus n plus 1. So here that's what we are going to do. The function we have, so minus 3 over 2 plus 1, our n, our power here, times u plus 1 minus 3 over 2 plus 1 from 0 to infinity. So here minus 3 over 2 plus 1, it's minus 1 over 2, so it's minus 2 here. And here we have u plus 1 minus 3 over 2 plus 1 minus 3 over 2 plus 2 over 2, so minus 1 over 2, so it's the square root of u plus 1. And this expression is going to be calculated between 0 and plus infinity. So In infinity, it's 0, zeros, it's minus 2, minus 2, it's plus 2. So the result is plus 2. Very interesting calculation, and the technique is the substitution. If you want to see the course, the main explanation of this technique, I have already shared a video on integration by substitution. You can find the link of this video in the description. If you liked this video, don't hesitate to like, to share, to comment, and to subscribe to this channel. It's really important for me, so that the channel can get more and more visibility on YouTube.